Hey guys, in this lesson we would go over the applications of slope, midpoint and length formulas that we have learned so far. We would be using some geometric figures such as triangles, rectangles, parallelograms, and we would be verifying their properties using slope, midpoint and length formulas. Let's understand all this with the help of examples. Let's say the first example is when we are given a triangle with vertices D, E and F. We have to show that this triangle is a right triangle. So we know right triangle means the triangle contains one of the angles as 90 degrees. So now we have to relate that 90-degree angle can be proved with which of the three formulas, because this is the application of slope, length and midpoint formula. So which formula is applicable to prove which property? That is what we have to decide and then use the formula to solve or to prove the question. Now here we have to prove if the triangle is a right triangle. Right triangle means the angle is 90 degrees between any two sides. We don't know if it's DE side, EF side or DF side, but we know one thing for sure, that the two sides that have a slope negative reciprocal to each other, those two sides are going to be perpendicular to each other, and perpendicular means angle is 90 degrees. So right triangle means any two sides are perpendicular to each other, and proving any two sides perpendicular to each other, we would require to use slope formula. So from here we get to know that this is an application of slope formula. Now what all we need to do is we have to find out the slope of side DE, then we would find out the slope of side EF, then we would also find out the slope of side DF, and we would see which of the two slopes are negative reciprocal of each other. If we find any of the two slopes is negative reciprocal, we can say yes, this triangle is a right triangle. So let's first find out the slope of side DE. We know slope formula is y2 minus y1 over x2 minus x1. So since we are finding the slope of DE, E is we are taking as x2 y2, so y2 minus y1, that is 2 minus 7 over negative 4 minus negative 2, which is equal to negative 5 over negative 4 plus 2, that is equal to negative 5 over negative 2. Negative and negative can get cancelled out. Therefore, we can say slope of DE is equal to 5 over 2. Similarly, we can find out the slope of EF. For EF, E we can take as x1 y1 and F we can take as x2 y2. It's y2 minus y1 over x2 minus x1. E point is known to us as negative 4 2. F point is given to us as 6 negative 2. We would do y2 minus y1, so it's negative 2 minus 2 over x2 minus x1, that is 6 minus negative 4, that gives us a negative 4 divided by 10, which is equal to negative 2 over 5. So this slope is for EF. Slope of EF is negative 2 over 5. Now looking at these two slopes, we see that these two slopes are negative reciprocals of each other. We need not even work on this third slope. So from here only we have found out that slope of DE is a negative reciprocal of slope of EF, because slope of DE is 5 over 2 and slope of EF is an opposite sign. That means here it's a positive and here it's a negative, and then numerator and denominator flipped here. Since there are two slopes that are negative reciprocal to each other, we can say as the slope of DE is equal to negative reciprocal of slope EF, this triangle is a right triangle at vertex E, because vertex E is common for both DE and EF. So if this is DE, this is EF, and it's going to be a 90-degree angle at vertex E. And this is how we prove if a triangle is a right triangle. Let's say if for the same question where we are given the triangle with vertices DEF, we are given another part to the question, and that is find the midpoint of the hypotenuse. Now we know the triangle DEF is a right triangle at vertex E. Therefore, the hypotenuse is going to be DF. Now, they want us to find out the midpoint of DF. We know the point D is negative 2, 7, and the point F is 6, negative 2. We want to find out the midpoint of D and F. Let's call this point as M. We are looking for X and Y of M. Therefore, we'll take the average of X of D and F point, -2 plus 6 divided by 2, which gives us 4/2, that is equal to 2. Similarly, we can get Ym, that is 7 plus -2 divided by 2, which is 5/2, and that's 2.5. Therefore, the midpoint of the hypotenuse is 2.5. Let's say if this question had another part to it, and that is show that this midpoint is equidistant from each of the vertices. Now we know the triangle is DEF and the midpoint was here, that was M. We have to prove that this point M is equidistant from E, D and F. Equidistant means length of DM, that is this, is equal to length of MF, that is this, is also equal to length of EM. Now from here we know that we would have to prove it using the length formula. So we would be finding the length of DM first. We can write on all the coordinates here for D, E, F and M. Now since we know all of these coordinates, finding length of DM would require the coordinates of D and M. We know the formula is square root of x2 minus x1 square. So it's 2 minus -2 whole square plus y2 minus y1 square. That is 2.5 minus 7 whole square, which is equal to 4 square plus 4.5 square. When we put this on the calculator, we get square root of 36.25, which is equal to 6.02. Because we're not given the units, we can just write down 6.02 units. Similarly, we can find out the length of MF, that is this line. And when we solve for the length of MF, we notice that we again get 4 square plus minus 4.5 whole square square root. That is going to give us a 6.02 units again. Similarly, we can find the length of EM, which when we solve, we get 6 square plus 0.5 square. That is equal to 36 plus 0.25, which is square root 36.25. And again, this would be equal to 6.02 units. And from here, we see that the length of DM is 6.02, length of MF is also 6.02, and length of EM is also 6.02 units. And from here we can conclude that the midpoint M is equidistant from each of the vertices, that is equal to 6.02 units. From this example, we can conclude few things, that if the question wants us to find out parallel or perpendicular lines, we can use slope formula. In this also is included right angles. So when the word right is used, perpendicular is used, parallel is used, we can use slope formula. If you're asked to find out the distance, or if you're asked to prove any given shape is a square or rectangle or parallelogram, or we are supposed to prove that a triangle is an equilateral triangle or isosceles triangle or scalene triangle. For all of these, we are definitely going to use the length formula, because if we talk about the triangle, a triangle with all 3 sides equal, or the length of the 3 sides are same, we can prove that it's an equilateral triangle. If 2 lengths are equal, we can prove that it's an isosceles triangle. And if no length is equal, we can prove that this is a scalene triangle. So this is about the triangles. Now, if you're asked to prove if a shape is a square, we know one of the properties of a square is that it has all 4 sides equal. So we can use a length formula to prove the 4 sides are equal. However, we also know that a rhombus has 4 sides equal as well. So we can use length formula to first find out the length of each of the sides. If all the sides are equal, we can conclude that it could be a square or a rhombus. So anywhere the question is talking about side lengths or sides, we are definitely using length formula. However, if we are trying to prove the shape of a given geometric figure, then we have to use a length formula in combination to slope or midpoint formula. For example, if we are proving for a square can be proved using a length formula and the slope formula, because a square is going to have sides at an angle of 90 degrees and all sides equal. Whereas in a rhombus, the sides need not meet at an angle of 90 degrees. Similarly, if we're asked to find out if a given shape is a rectangle or a parallelogram, we know rectangle opposite sides are equal. So this is equal to this and this is equal to this, and that is the case in a parallelogram as well. Opposite sides are equal and parallel. However, how can we differentiate between the two shapes is that here the angle is supposed to be 90 degree. Here the angle is not supposed to be 90 degree. So if the side lengths are not negative reciprocal of each other, but they are equal and parallel, then we can conclude it's a parallelogram. Anywhere if the question wants us to find out if two things or if two lines bisect each other, or the question can be asked as one side is half of the other or double of the other, then we can use the midpoint formula. For example, if in a certain figure the question wants us to find out that the diagonals bisect each other. Bisecting means meeting in the middle of each other. So then we would have to find out the midpoint of each of the diagonal. If it's a common point, we can say yes, the diagonals bisect each other. Another type of question where they want us to find out if the line segment formed by the midpoint of the two sides of a triangle. So let's say this is one side and this is the other side. D and E are the midpoints of AB and EC, and they want us to prove that DE is half of BC. So we can first find out the coordinates of points D and E by using the midpoint formula of AB, as D lies right in the middle of AB and E lies in the middle of AC. Once we know the 2 points, then we can use the length formula to prove if this side is half of this or not. So half, double, this can come using the length formula as well. And this is how different formulas can be applied to prove the properties of geometric figures or shapes. We would either be required to use one formula for one question, or there could be a combination of formulas for a question depending upon the properties of different geometric figures that have been learned in previous grades.